Let's talk all about AI in business. It's hosted by Brent Muller. Welcome to the Future Proof Podcast.
Hi, and welcome to the latest episode of the Future Proof Podcast. I'm your host, Brent Muller. Today, I'm really excited to be joined by Allan Grosvenor from MSBAI. Allan, great to have you.
Glad to be here.
Yeah. So, Allan, I always start with, kind of the founder's background. So just tell me a little bit about tell us all a little bit about your background and kind of your journey to MSBAI.
Sure. Well, I'm an aerospace engineer. Started doing that like 25 years ago. When I was a child, I didn't like school so much, but I loved science fiction and decided I was going to try to figure out how to do that stuff.
Love it.
That's how I started getting into aerospace engineering and did that for a while in aviation, also power generation and space launch, and eventually started my own company. In some of the small companies I worked for first, we were using government supercomputers on some extraordinarily challenging, ambitious projects that were surpassing what's possible with the standard design rules, where computational physics simulations enabled us to try concepts that have never been tried before. And I started getting access to Department of Energy supercomputers at Oak Ridge National Laboratory, and then later at Department of Defense supercomputer facilities like the Air Force's Supercomputer Center. In those projects, ended up building the constituent parts of what I eventually realized I should turn into my own company. And that's when I launched MSBAI to make it easy for lots of folks to do very productive design, analysis, industrial kind of work with the latest, most powerful compute.
Really, really cool. So that leads you up to starting MSBAI. So talk to us about your vision for MSBAI, because it's evolved, right? And like anything, that's natural, right? For the evolution to happen where you start solving more problems that you probably didn't set out to do. But talk about your initial vision and kind of where you are today.
Yeah, it really started off with a particular focus on engineering, modeling, and simulation. I worked at a small company called Ramgen Power Systems for a while that had a big Department of Energy funded contract where we were designing and building and testing something that had never been done before. Turbo machinery that can operate at supersonic speeds. Turbo machinery that pretty much everyone has seen. One example is when you walk onto the airplane and you look in the nacelle and you see those fan blades. That's an example of a turbo machine. Those are the axial compressor rotor blades that you're seeing.
Right.
The tips of those rotor blades, usually what limits the speed that you rotate those at is that you get to around the speed of sound at the tips. And if you rotate them any higher, you get such strong shock waves that you'll deteriorate the stability and performance of the engine. You would get a lot more compression out of the engine and you would get higher performance if you were able to go supersonic. But at Ramgen, we discovered that you need a radically different design in order to do that. That was the first way I started using supercomputers. And I was very lucky to have access to supercomputers at the Oak Ridge National Laboratory, first the Jaguar system, then the Titan system, where I started doing that about 15 years ago. A little bit later, I worked at a company called Maston Space Systems, a reusable rocket launch company. And we had just won, soon after I joined the company, the DARPA reusable space plane program. And we started using Air Force supercomputers at the Air Force Research Lab to, again, in this project too, try design concepts that had never been done before, running lots of computational physics simulations, simultaneously running massive trajectory studies, as well as vehicle configuration, aerothermodynamic simulations that we were running like 1,000 at a time, studying the entire mission space to discover the right combination of both trajectory and the flight vehicle configuration that could do it while minimizing cost and maximizing reusability. In both of those programs that I talked about at Ramgen and at Maston, we designed technology that had never been done before on the supercomputers first, then tested them in full-up prototype testing, and in both cases confirmed our predictions, which was
That's
a real
really cool
game changer. And it really changed my life. Doing that is not easy.
I can't even imagine.
Yeah. And, that kid that was watching the science fiction movies, little monkey goofing around in class and eventually discovering that, physics and calculus and computer programming, you can use that to do some really cool stuff. That was...
You're giving every kid hope, right? Out of all the things like that they hated in school, all of a sudden they were like, hey, this actually, brings what I thought in my head to life. Really cool.
Exactly. Yeah. Choose what you're interested in, do it as a hobby, figure out how you can make it your career. I've been very blessed to be able to do that myself.
Yeah. You're one of the rare few, which is awesome.
So lucky. Something that I discovered in doing so, there are so many different ways that when you're running any kinds of these things on a lot of compute, like I was at the supercomputer centers, that there's innumerable ways you can get it wrong. You can do it inconsistently. You can have limitations on the number that you can run or how you process it, et cetera. So we started building different ways to automate it and increasingly more sophisticated ways. And eventually I discovered, this could be its own company. Just the tooling that we were building to do that work ought to be its own company. That's how I started getting the idea to start MSBAI.
So if I add deeper a little bit on that, when you're doing these simulations, it almost seems like you were doing AI before AI, right? Because really, it's really what you're talking about is machine learning, and maybe not deep learning at that point, but simulators had to be a component of that.
Yeah. And it's so funny that people think about AI like it's a new thing. And it makes sense why they think of it that way, because there's been such a radical explosion lately in the capability. But, John McCarthy came up with the term artificial intelligence in the 1950s. 1950s and the 1960s, where we had the first symbolic artificial intelligence, the first perceptron architecture. And then, of course, in the decades between then and now, we've had radical advances in all those techniques. Much more recently, we had reinforcement learning emerge and really started making some strides in the 80s and 90s. In the 90s and early 2000s, convolutional neural networks came into being, and we started demonstrating amazing outcomes of those. But then, of course, it's just 2017 that we got the transformer network published for the first time. A few years later, large language models started being a thing. Right. More recently, the joint embedding predictive architecture that's come out that's made a radical difference in solving a lot of the fundamental problems with large language models, why they hallucinate, why they lie to you half the time.
Right.
And many more advances since then that we're very fortunate to be working on and incorporating into our technology.
Yeah, that's what I love, is that talking to folks like you, I know that you're kind of out on the forefront. You've seen this, you can kind of see the trajectory better because you've been using it for years and years and years. Other people didn't know it until OpenAI really came out. And they, the vast majority of the world, right? That's when they opened their eyes to it. So I've talked to several folks on podcasts in different industries like yourself that have been doing it for 20 plus years, right? Just in different forms. And I think the neat part about this is you probably have a better crystal ball of where it's going than everybody else, right? Not that anybody can predict out past a couple of years, but at least you could see, hey, look, we did this. This is our next step, because you're playing with big toys, supercomputing and algorithms, and it's fantastic. So, but before we even dive into that and the outlook, I really want to hear more about MSBAI and because you've expanded, right? You started out in space and aviation, but now you're in a bunch of different verticals. So for everybody out there, kind of give them a little taste of how this technology is helping other industries.
Yeah, we're extraordinarily lucky that in 2020, we started engaging with the Air Force and then the United States Space Force when it came into existence, and started attracting business from small companies like ours. And we started working on some extraordinarily ambitious goals. We're very lucky that the Supercomputer Center, AFRL, DSRC, that's Air Force Research Lab, DoD Supercomputing Resource Center, that I started working with more than 10 years ago when I was at Maston Space Systems. Now they're our customer. And we installed our Guru. Yes. And we installed our Guru system at their facility, enabling their users to take minutes to set up simulations of aircraft, launch vehicles, for example, in minutes, something that used to take people hours or longer to set up. We also have been working with the United States Space Force on a lot of space operations problems. We've delivered to Space Systems Command some services that are essential to space traffic control. The exponential increase in the number of launches of satellites lately, all thanks to SpaceX, by the way. The radical increase in rate of launches and radical decrease in cost of launches has opened up and made possible a bunch of business plans that never closed before. And so the exponential increase that's happening right now in that amount of traffic means that you need autonomy in every part of the process of making sure that everything is moving and coordinating and engaging, talking about rendezvous proximity operations of a servicing satellite or with a space station. All that's happening safely. There's very few ground control operators. There's never going to be, 1,000 times the ground control operators as there are today. So you got 1,000x their capabilities by giving them as much artificial intelligence as possible to handle their workload, to give them early alerts, sanity checks, etc. Now, we started off with those kinds of applications first. There's so much more we're getting into, including building and delivering some of those capabilities now on board spacecraft and on board other kinds of aerial vehicles. Also, we have entirely other commercial areas that we've grown into. The benefit for us is that when you start working on hard problems like that first, problems where the AI when the AI must not make mistakes,
right?
And you have to build and train that and deliver it to the customer first with these kinds of ambitious goals, it ends up setting you up really well for some other extraordinary challenges. One example of that we've been working on for the last 3 years and starting to grow a lot lately is we have a branch of our company working on finance.
Of all things, right?
Which, by the way, is something I never imagined I would get into with artificial intelligence, because when I was in grad school, aerospace engineering friends of mine were being plucked out of the aerospace engineering field and going and working on Wall Street. And I thought,
really?
Yeah. And that was a very long time ago. That was decades ago. And I thought to myself at the time, I thought, if you could work on spacecraft, if you could work on the kinds of brand new aircraft that fly at Edwards Air Force Base, very, very near to my backyard here.
Right.
For that kind of experimental, cool, advanced stuff, why the heck would you go and work in finance? And I thought, furthermore, that must be a really saturated application field for artificial intelligence. So that's got to be the last thing I'm going to go and work on. And yet I'm very lucky.
Yeah.
Very lucky to be working on it. And it was actually a customer and now also investor in our company that approached us and had a long conversation, our first meeting, about his vision, what he wanted to do, what he thought was not met yet as a need for autonomous trading, arbitrage, some other liquidity pool kind of opportunities that would be a beautiful fit for the kind of autonomy and artificial intelligence that we work on. And I discovered that actually he's right. And there's actually a huge amount of room. The beautiful thing about all the stuff that we're doing, both on the aerospace side and on the finance side and some other areas that we've been getting into lately, is there is not a scarcity of opportunity. There are some industrial areas, there are some market opportunities where you are a tiny fish in a vast ocean of competition and you're all just struggling to grab a piece of it, and you're bashing each other because if somebody else gets this business, then you're not getting it. There is abundance of opportunity in these areas that we're particularly working on, and there is so much new opportunity that's growing as a consequence of all the latest that's been happening with artificial intelligence and also with the digital economy, that we don't find ourselves competing with anybody. We find ourselves finding very niche slot areas that we end up doing very well, and customers that want to work with us. And that's been extraordinarily exciting.
Well, and Allan, you hit on that. I think a lot of people make assumptions about that. We're all guilty of it, and thinking that everyone's got everything figured out. And when you realize it, you start to, dig in, you realize there's massive opportunities. And part of my podcast has always been, you can look at AI or emerging tech or any of this as an opportunity, glass half full, or you can fear monger it and half empty and the world's ending. And I just don't believe that. If you look at history, this is just the next set of tools to open up and expand our world. I think what you just hit on is that, people have been talking about, I have people that have watched my podcast and they're like, oh, I've watched Billions. Are you guys talking about quants? And I'm like, no, that's not what we're talking about, right? And what AI is doing, and correct me if I'm wrong, I would like you to expand on this, is that what it's allowing you to do is both quantitative and qualitative, but really crunch things and solve problems at a faster level than has ever been capable. And because you solve such harder problems, it's easier to bring it commercially and solve these problems. Am I thinking about that right?
You're 100% correct. By the way, I love Billions.
Yeah, I do too.
Actually rewatch those shows. And I particularly loved the earlier seasons, I must say. But
Me too.
So the quants in the chairs on Billions, those were individual specialists. And later in the show, actually, they actually brought in some artificial intelligence too, but they didn't talk too much about the details of how that thing worked.
Right.
But the thing is that, when people think about artificial intelligence these days, they're generally thinking about large language models. Very important, and also like a tiny sliver of the spectrum of methodologies and opportunities to solve problems. One very underappreciated problem by some people, let's say, or let's say the uninitiated, when it comes to finance, also any kind of operations problem, is you have generally streams of lots of different types of data coming from different sources. And there's all sorts of problems that you have to solve that becomes a lot more of a systems engineering problem than a fundamental AI problem first. You have streams of data that are some kind of complex time series problem, let's say.
Right.
Whether it's satellites in some orbit around the Earth, and you have a time varying nature, at different scales of time, prior orbits that you're going to have, a year worth of data, and then let's say hours or days of their latest movements, and then you have some kinds of sensors that will give you even tighter granularity of those movements than that. On the finance side, you'll have some data that you're getting in that's giving you minutes kind of resolution of data, and others that are more like hours resolution of data, and they are not synchronized. And furthermore, there are all sorts of reasons why when you're drawing those data streams from the different places that you're getting them, they will move out of synchronization. They'll have all sorts of individual problems at some moment in time. And if you're not actively, constantly monitoring that and constantly resynchronizing on your end, also, if you have not built a robust enough and fault tolerant enough system that all of a sudden, when you're not getting any data at all, or if you're getting all sorts of non-uniformity in the intervals of the data that you're receiving, then it doesn't matter what else you may have done or how you may have trained some model, for example, it ain't going to work. So that's I guess one example of something that we learned the hard way on the defense side first, that we started continuing to benefit from as we were expanding into a variety of commercial spaces. And I also wanted to briefly go back to a question that you're asking about earlier, as it corresponds to what you're talking about here. You were talking about predicting the future of AI. And one secret I'd like to volunteer on how I've been predicting the future of AI is by reading literature that is 1 or 2 or more decades old. So, for example,
this will be interesting. Yeah, please elaborate.
Absolutely. Lately, you hear people talking about agentic systems, agent-based intelligence, and multi-agent systems. And the term agentic is a relatively new term. People that have been in this a little bit more recently think like, oh, this agent-based artificial intelligence, that seems like a new thing, but actually it's a decades old thing. For example, you can pick up for free by a quick internet search using your favorite search engine, The Society of Mind by Marvin Minsky. In that book, he's talking about a society of agents. That was an example of literature from several decades ago that I first started learning about and thinking about multi-agent systems with individual skills that you train over time and then build a comprehensive system. Again, very much a systems engineering problem to coordinate and build and superimpose on each other and produce a more comprehensively intelligent system. Another book I love that's a little bit old now, it came out in 2010, is Embodiment and the Inner Life by Murray Shanahan. And for anyone who has seen the movie Ex Machina, that was the book that inspired the creation of that film. And again, in Embodiment and the Inner Life, there are a lot of fundamentals about global workspace theory that are decades old that are essential to modern artificial intelligence strategies that you're seeing being fleshed out in state-of-the-art systems now. There's many more nuggets in those books that I think we're going to continue to see materialize.
Right.
So one way to continue predicting the future is go back and read those books a few more times.
Yeah.
That's what I've been.
That's fantastic. I'm going to get them both. So, yeah.
I strongly recommend, and you can get them both for free on the internet. Marvin Minsky's book is, I think, it was published in the 90s and was long released publicly for free by PDF. You can get it all over the place. And then Murray Shanahan put his book out for free by PDF on the internet. And I think you just search Twitter X and you can find it that way. I brought up that in the context of what we were talking about, the quants and billions, and they were human agents, separately trained and highly specialized traders with their individual insights and individual methods, different types of data they were using to make these trading decisions. And when they were acting as a whole, as a team, they were accomplishing some extraordinary wins. And likewise, multi-agent systems today, I think, have extraordinary potential to solve some huge unmet needs. And particularly when they're teaming with humans, you take human experts in a particular area, you give them the right kind of multi-agent artificial intelligence system and to scale up their ability to do what they're experts in at scale and have more sanity checks, more insights, more alerts, more prediction. I think the future is very bright. I think that we're entering a new renaissance in innovation, for example.
I agree with you. I really do. And the more people like yourself that we talk to every day, it gets more and more exciting because we're solving problems faster. So you're seeing innovation faster. And it's really exciting. And we have a saying on the podcast that right now where AI is, and again, you're at a whole nother level with the simulators that you're doing and the access to the supercomputing, where the general population that has access today, we tell everybody these are digital coworkers. There's a reason why Copilot was named, right? What it was. It makes human agents that much better right now. Where it's going, right? Different story down the road, right? Who knows? I mean, we can all see where it's going down the road. But right now, I feel like this is where the humans using AI are going to innovate like no tomorrow. So I don't know how you feel, Allan.
100%, and just going back to the aerospace engineering stuff that I was doing earlier in my career as a design engineer and analyst as well, it takes so much time to take your concept think about any kind of product idea that you might have, to actually build a virtual prototype of it on the computer, and then to simulate it, to run simulations to figure out, is this going to be manufacturable? Is it going to be lightweight? Is it going to be strong enough? Is it going to be high performance enough? And it takes so much time to just set up the models, to set up the simulations, then to run them and to then extract the insights that you need.
The insights, right. Pull the insights out. Yeah.
To actually know what those are telling you and how they should drive you to update the design. It takes so much time that you're very limited in the amount of iterations that you can actually take. So it's a real game changer if you can actually totally minimize that time and focus again on what you actually cared about in the first place, your design.
Right.
And so that's one of the reasons why I think we're going to see a lot of innovation. A classic example is you look at a transatlantic airliner, and one that came out in the 90s, 60s, 70s, up until today. And it's a long, slender tube with a big tail at the back and long, slender wings coming out of it in the center, usually with potted engines hanging off of
either
the
way.
cell.
Right.
And they've really changed very little over the course of decades. And we're starting to see a lot. Yeah, absolutely. And we're starting to see a lot more changes happening now. And it's because actually aerospace industry, aviation, particularly designing those kinds of aircraft, adopted simulation first. And that's why in the last decade or two, you've been starting to see radical changes in the individual shapes of components and of these aircraft. And if you squint and look closely at the fuselage and wing shapes and tail shapes and nacelle shapes, you actually see some tangible differences that started emerging. But now entire aircraft configuration changes are starting to happen. And that's starting to happen in many different types of products across multiple industries now. And it's really going to be accelerated as a consequence of all this latest stuff. Simulation plus high performance computing plus artificial intelligence, where, when I started using government supercomputers 15 years ago, they were petaflops scale systems. Everyone watching this podcast now can go and rent time on a petaflops scale system from a commercial cloud vendor today. And so
it's crazy, isn't it?
Yeah, it's totally crazy. Things have been moving so fast and it's only accelerating.
Yeah, honestly, Allan, I totally agree with you. And I think that for that part, it's really, really exciting. So before I ask you our final two questions, we'd just love to, you talked about the future by going back to some of the books in the past, right? But as you look down the next 1 to 2 years, what do you see are some of the biggest impacts? Because you've obviously seen the trajectory up close at all these different components of AI that most people don't even understand outside of LLMs. Where do you see things going in your mind?
The way I see things going is, there's a sometimes controversial figure. There's a lot of controversial figures out there,
Tons,
of course.
Yeah.
But a gentleman named Yann LeCun, one of many pioneers. I've already mentioned other pioneers in artificial intelligence. Yann LeCun is one of the people we have to thank for the convolutional neural network. And he leads Facebook AI research. It's because of the Facebook folks that we have Torch, for example. More recently, it's due to them that we have the joint embedding predictive architecture. The transformer mostly came from Google. So in 2017, transformer came from Google. In 2020, large language models emerged mostly depending on transformers. Joint embedding predictive architecture is a way to train a model architecture in a manner that learns from higher level semantic understanding as opposed to, let's say, pixel level or time series level kinds of data. So there's a lot more that you can gain with that kind of architecture. He's already talking about new architectures that are essential to so-called hierarchical planning, a system that is able to do higher level decision making for complex planning. Think about what everybody imagines when they think about futuristic AI and what they would like it to do. Well, the kind of catastrophic forgetting and hallucinating that large language models are usually doing when you're using it for anything serious. There are newer architectures and again, more systems engineering to be done in order to build hierarchical systems that are capable of memory, of decision making, of planning. And I think we're going to see a lot more coming from that. And again, going back to the basics, some of the old classic books that talked about this from a systems engineering standpoint, talked about it from a neuroscience standpoint, learning from the human brain and animals and how they work, and then conceiving then of what artificial intelligence is going to need to be like. There's so much more that we're going to start seeing emerge that are going to prove some of those old books true.
Yeah, no, it's fantastic. Fantastic. All right. So I told you I was going to ask you a couple cool questions at the end. One, what's something cool, Allan, you've done with AI personally, or something that just a tip or trick that another founder or CEO would find really
Absolutely. I use lots of different AI tools all the time. Name all of them. I am a regular user of Claude and Perplexity and ChatGPT and so many others that I use to generate prototypes of a concept that I'm thinking about, also analyze a plan that I have and tell me what I'm getting wrong, to go out and supplement my research. I use Mid-Journey to sometimes just sketch ideas that we use internally.
I love Mid-Journey. Yeah.
And, and I it, so generally, I think I'm using a lot of different AI tools to do research quicker, and like including market research quicker. And also, once I've produced a plan, then to tear it apart and give me all sorts of feedback. And then, of course, then I go and ask it, okay, well, if this is a problem, then what do you recommend? And I'll generally get a lot of different ideas that I can then go back to my team and flesh out more. I think more and more AI, you can use it as a teammate. More than 10 years ago, I used to have my laptop connected to the Wi-Fi through my phone on long drives to where I worked at the time in Mojave and back. And I was using text-to-speech and speech-to-text then, and I was using it to execute script commands, driving systems I was logged into from the laptop. I think we're going to be doing a lot more of that on our phone. I think it's about 80% of humanity that have smartphones and maybe only about 40-50% that have laptops. I think we're going to get closer and closer to 90 or 100% of humanity that have smartphones. And we're going to put so much more onto the handset, give people direct access to these tools, and really use it more and more as an assistant, a flexible assistant that's able to, if you want, look at you in the camera as you're gesturing and say, make it bigger. And you can talk to it, you can type in stuff. I think there's so much more that we're going to have there. But we've been building Guru to do that already. And there's so much more to come.
That's awesome. That's awesome. I love it. Thank you. And then last thing is, talk about your growth goals. And like I said, if I give you a magic wand, you could fix one thing. What would that be to help MSBAI grow and exceed, right, your 2025 targets?
Thank you. I do a lot of context switching, because one moment I'm talking to someone about a brain that we're going to put on top of an autonomous vehicle to make it fly differently than it usually flies. And
right.
Then I'm talking to somebody about how we're going to start trading Solana and not just Ethereum and stablecoin. And then I talk to people about how we're going to help them with a problem they have with land use permitting. And I need to grow my team more so I can have more help in this kind of context switching. But it's really exciting. We have a lot of backlog on new contracts that we're starting up, and we have been launching new endeavors in entirely new market verticals that are all great fits for the kind of, let's say, intelligent that you can trust hierarchical systems for driving complex workflows. And this year is like a really massive growth year of us. And I just got to make sure that I'm constantly switching contexts and handling all those individual disciplines.
Yeah, well, that's a good problem to have, right? But it is hard because every industry has its own nuances. So yeah, every time you switch, you got to put that hat on. So maybe some of the cool AI tools will help you keep up with all the acronyms and stuff that each of those have.
Specialized industry-specific terminology.
Yes, I love it. I love it. Well, Allan, thank you so much for spending time with us. This has been really, really cool stuff. For everybody that is listening and say, hey, I want to talk to these guys. How do they talk to you about Guru and enter one of these industries?
Absolutely. Well, you can search for us using your favorite search engine, MSBAI. Guarantee you'll find us. Also, you can go to our website via msb.ai. You can email me at by Allan at MSB.ai. We got lots of socials. We're on Twitter, X, Instagram, LinkedIn, all those.
Awesome. And we'll have all those links below once this podcast goes up in live. So, Allan, thank you for spending time with us. This has been fantastic.
Thank you, Brett.
Yeah. Hey, for the latest episodes, just go to our website or just follow us on our YouTube channel. Thanks, guys, and we'll see you on the next episode.
If you're ready to embrace change and lead with innovation, be sure to subscribe and never miss an episode. Thanks for tuning in to the Future Proof Podcast.